Now in this problem, 83, again, we're going to use the rule of exponents. Now I know I can distribute here, and when I distribute, I'm going to be multiplying, so I'm going to add the exponents. But let's just distribute first. Maybe just one step at a time here. So we're going to get p to the 1/3 times p to the 2/3 plus, right, plus, okay, here's the first one, plus now p to the 1/3 times this one here, 3p to the 5/3. Now we're multiplying two powers with the same base here, so we're going to add these exponents. Multiplying two powers with the same base here, so we'll add those exponents. Here's what it'll look like. It will look like p to the 1/3 plus 2/3 plus, let's write the 3 out in front as our coefficient, p to the 1/3 plus 5/3. This gives us p to the 1/3 and 2/3 is 3/3 plus 3p to the 1/3 and 5/3. That's 6 of those thirds. But we can simplify this. P to the 3/3 is 1 plus 3p to the 6/3 is 2. And we don't need to write this 1 here, so let's just simplify this as p plus 3p squared. So in 87, again, like 83, we're going to multiply through here. We're going to distribute. So we're going to get 2a to the, now, we're multiplying powers with the same base, so we're going to add these exponents. So this is going to look like this. 9/2 minus 9/2, right? It's 9/2 plus negative 9/2, or just 9/2 minus 9/2. And then plus 2a to the 9/2 plus negative 5/2, or just negative 5/2. And now this will give us 2a to the, well, 9/2 minus 9/2 is just a 0, so we'll get 2a to the 0 plus 2a to the, no, 9/2 minus 5/2. 9 minus 5 is a 4, so we'll get 4/2. And assuming now that a is not 0, you remember what this is? A to the 0, a non-zero number to the 0 power is 1. So we're going to get 2 times 1 plus 2a to the 4 divided by 2 is a 2. Let's finish it off. 2 times 1 is 2 plus 2a squared, and I think we can leave it at that.